From the classroom to the workplace, we work, we work. When we see the complete picture, we work in the classroom towards our future. We work.
My name is Khadija Banatine, and I'm qualified as an engineer. And I'm currently an engineering technician for Linestep Barbados. My studies in mechanical engineering have helped me to understand the machines I'm working with, and I will now take you through the process of creating a lens. In the process of making a lens, there are certain procedures that must be followed. Basically, the technician is responsible for making the lens and also responsible for setting up the computerized lathe. Before we can start, we must first read the specification sheet allocated for the particular model of the lens being made. After the model is selected, in this case we are making a Softet 1 model, the technician then loads the preset program on the computer, entering the power of the optic or the diopter of the lens being cut. Diopter is the unit of the power of magnification of the lens. The optic of a lens magnifies like a magnifying glass, and different optics will magnify more than others. Once the lens have been finished cut, it is then removed from the machine and taken to be measured to ensure that it meets the requirements on the specification sheet. If there are any adjustments to be made, then the technician returns to the lathe and makes the necessary adjustments. The process of cutting is repeated until the measurements are within the specifications. After the concave side of the lens have been cut, the next step is the blocking process. This is where the concave side of a lens is placed onto a metal block that has been preheated to a specific temperature. We then move on to cutting the second cut side or the convex side of the lens. Convex is where at least one surface of the lens curves outwards like the exterior of a sphere. Before we can cut this side of the lens, we must first cut a squid, which will be made of blue material in order to take our dimensions. Once the squid has been cut, the dimensions are taken and measured, and adjustments are entered into the program on a computerized lathe for the second cut. Once the second cut has been completed, the lens is taken from the machine and removed from the block, where some dimensions are checked on the lens to make sure that they correspond with the specification sheet. If no further adjustments are necessary, the machine is then given the go-ahead to run. After the convex side has been cut, the milling process takes place. Basically, the milling process is another preset program in the computer where the actual shape of the lens is being cut out. As you can see, the technician will check the specification sheet for the particular model once again and load the corresponding program. Once this lens has been set to cut and is completed, the technician removes the block from the table and checks that the lens is within specification or within the tolerance range. This is done by placing the lens onto the profile projector and utilizing an AutoCAD drawing. As you know, AutoCAD is basically a computer-aided drawing. Once the AutoCAD drawing is placed onto the profile projector, the lens is focused and adjusted to fit into the drawing. Measurements are then taken to ensure that the lens is within the specified range or tolerance range allowed. If it happens that the lens is too big or too small or falls outside of the tolerance range, the technician then returns to the milling machine and readjusts the program, and the process is repeated until the lens falls within the specification or tolerance range. Once the setup technician has verified that the dimensions are within specification, quality control performs their final verifications, and the machine is then turned into the production mode.
So you have just seen that computer-aided manufacturing is very important in the making of a lens.
From the classroom to the workplace, we work, we work. When we see the complete picture,